Hi everyone, I'm going to discuss my presentations. I am as ICT 5205 implementing an image object identification systems on a system on AWS. Now I'm going to show my projects for building an intelligent image object identification system right now in the cloud. In this project, I combine a powerful deep learning models called AL of B5s with serverless cloud systems on AWS. I will explain how I design these systems, how the parts talk to each other, and the final result of my test. And then is second slide is the introductions and project objectives. The main goal: build a scalable image of recognition platform. Look it and this main objects of my assistance is to create a smart automated pipeline that can take my any fixers, look at it, and instantly tell us what objects are inside it. To do this heavy machine learning works, I saw the state of art ELO B5's model because it is very fast and high accurate. And the third is the system architectures and workflow. Front into point Amazon Sapphire Gateway and the core route and brain AWS Lambda micro service. Now this service, this system works. Architecture diagram on the screen. This map show the exactly how data are travel through my cloud network. First, a user sends a simple HTTP post request to Amazon API gateway with the name of the image they wants to scan. API gateway fetches this trigger directly into my AWS Lambda functions. This lambda functions then grab the raw image by bytes from Amazon as three storage buckets and systems it over the network of to my Amazon ICT to instance. And then the IC2 server runs the YOLO-B5 model code figures of what objects are inside. And third is let's talk through methodology of setting in the systems in the real world. I started going to the AWS console and publishing Amazon 3 bucket, and then the topic is number is 5. The after setting the security layer, I build the database table and the combinations are in the left screenshots. You can see that I created an Amazon Diamond D and with DB tables named yellow detecting results. I set the main for partitions case image ID, so the every single image can get a unique tracking number. On the right side of the slide you can see my action active Amazon EC2 instance running on an onboard to Linux operation system. I configured customers firewall security groups on this instance to allow incoming traffic on port of 5000. This is the open door that my Lambda functions uses to stream image files over to the server. And the next slide is ULB5 models, architecture, or the store activations. Once my service server was off, I use a terminal to clone the official open source ULB5 repository for GitHub. As you can see in this screenshot on the left, I verified the model environments directly on the EC2 command line to make a sure PyTorch and of OpenCV are working perfectly. And then next topic is output results discussions. And now I list to talk about the output result the discussion. My result which was the most exciting part of the testing to verify that my entire pipeline worked perfectly from end to end. And I sent the test request within the file name the bus.jpg, as you can see in the left screenshot. My lambda function successfully execute and processed the image. On the right side you can see the result instant the Amazon API gateway console. The system returned a perfect HTTP 200 success code and correctly outdated the model text answer which read for person. And the next slide is the storage and database log verification results. JSON files generated automatically with with the distance keys. Permanent files storage verified inside the S3 result directly. No non-SQL database entered the index automatically in real time. Log files captures image, ID files, names, and result, and um, templates. All templates, the right screenshot show the my live Amazon Dynamo DBID I tables layout. Every time you use uploads an image, a new row is added here automatically. It nearly logs the unique name, image, the file name, the exact object found, and the exact executions timestamps. This ensure your data is safe and fully auditable. And the final next slide is performance running resource optimization. In the final part of my project, I focus heavily focus on performance optimizations, streaming raw image bytes across the network, and introduce noticeable latency because AWS Lambda ties its eternal CPU speeds directly to how much money you give it. I decided to scale up its resource for file. As shown in this console screenshot, I increase the allocated memory limits of 124 MB. This immediate books boosted the processing speed. Also monitor a code start. The very first time I can run the systems, it look about 23 seconds because the cloud content had to build from scratch, but on all consecutive runs, the system stayed warm and the response time was nearly instant. And the next slide is a conclusion in a project. This project gave me wonderful hands-on experience in cloud engineering. I successfully deployed a complete deep learning systems on AWS that perfectly connects file storage perfectly connects serverless systems with a live neural network model. All my data files, the database logs, and file storage metrics are working reliably. Thank you so much for listening to my presentation. I'm happy to answer all questions you might have about the about my implementations. Thank you, sir.